Welcome again. So I have a problem to solve here, testing an application of Cauchy's residue theorem. So we have to evaluate the integral along a unit circle about the origin of the function 1 over z sine z. This is a solution. So you say here, f of z is given by 1 over z sine of z. So the poles of f of z are solutions of z sine z equals to 0, which implies z equals to 0, or z equals to n pi, n equals to 0, plus or minus 1, plus or minus 2, plus or minus 3, etc. Now let's see how to play with this function. F of z is 1 over z sine z, which can be written as 1 over z into, so we write sine z as a series, so z minus z cubed over 3 factorial plus z power 5 over 5 factorial minus z power 7 over 7 factorial plus other terms. So this is how we write today, or how we can write the function 1 over z times sine of z. Then the same function can be written as, now you see z is common here, we can factor it out. So we have 1 over z squared into, now 1 minus z squared over 3 factorial plus z power 4 over 5 factorial minus z power 6 over 7 factorial plus other several terms. And you see, we can rewrite this one as f of z equals to 1 over z into 1 minus z squared over 3 factorial minus z power 4 over 5 factorial plus z power 6 over 7 factorial minus other several terms. And then now, because this was a denominator, then remember this is a square, I raised to power negative 1. So I've been able to express this series in the form 1 minus x or negative 1, whose series is 1 plus x squared plus x cubed plus x power 4 plus several terms. So using this binomial theorem, this can be written as f of z is equals to 1 over z squared plus 1 over z squared into The first term is 1 plus z squared over 3 factorial minus z power 4 over 5 factorial plus z power 6 over 7 factorial minus other several terms plus z squared over 3 factorial minus z power 4 over 5 factorial is factorial plus z power 6 over 7 factorial minus other several terms, and then square plus z squared over 3 factorial z power 4 over 5 factorial z power 6 over 7 factorial power 3 plus other several terms of the same pattern. Now, when you multiply by 1 over z squared, so you have f of z will be 1 over z squared plus 1 over 3 factorial, and then minus z squared over 5 factorial plus z power 4 over 7 factorial minus other several terms, and then this z 1 over z1 times these other terms. So which can be written as 1 over z squared plus 1 over 6 minus z squared 5 factorial is given by 120, and then plus z power 4, so 7 factorial so 1 z power 4 over 50, 40 plus other several terms. So remember, the interest is to find now the residue of the function. So since there is no possibility of obtaining a term of the form b1 over z then we take b1 to be 0, hence the pole, hence the pole z equals to 0 has so hence the pole is z equals to 0, and integral along C of 1 over z sine of z dz is given by 2 pi I times sum of residues and the sum of residues in this case is 0. So 2 pi I times 0. So that integral will give us 0. So therefore, the given problem has its value equivalent to 0. Thank you.